Okay, welcome back. So here we're just picking up right where we left off on this first ANOVA exercise, where we went through and completed a full ANOVA table, and we found here that we rejected our null hypotheses. The null hypotheses being that all three of our treatment means are equal, the alternative saying that not all of them are equal. So having obtained enough evidence to reject that null hypotheses, so in the context of our case, we've got all these different toothpaste whiteners, I can say, well, at least one of these different treatments is different from the others. At least one, maybe all three of them are different from each other. So the question now, of course, is to identify, well, where is the difference? Which one is different of these three? So the methodology that we'll use is called Fisher's LSD. And Fisher's LSD is actually a fairly straightforward approach. It's effectively a series of two-sample t-tests with some slight differences. What we'll do now is we'll set up all pairwise comparisons. So again, this is one of the reasons why we only work with 3 treatments when we're working through these by hand, because it significantly reduces the amount of work that we have to do. What we'll be doing, I'll write out our hypotheses here, is we're going to be testing. First, let's test to see if mu A is equal to mu B or not. Then we'll test to see, is mu A equal to mu C or not. And finally, we can test to see, is mu B equal to mu C. So you can see with only 3 treatments, we end up with just 3 pairwise comparisons. If I had 4 treatments and 5 treatments or 6 treatments, you can see how the number of pairs that we can compare will increase quite rapidly. So how do we do these tests? Well, it's similar to our Chapter 10 exercises, but with some subtle differences. Basically what we'll be doing, let me give myself some room here, is we have a straightforward rejection rule. First of all, we'll calculate this thing called the LSD, or the least significant difference. And you might recognize this formula. It's very similar to what we used when we were calculating confidence intervals for 2 different populations, but of course here we have a little bit of ANOVA sneaking in there, because our best estimate, our best unbiased estimate of the variance, it's not a sample variance anymore. Now it's MSE, the mean squared error, coming from our ANOVA table. Then to perform the tests, what we will be doing is comparing each of these differences in sample means, so I and j corresponding to our different sample means, and we compare this to our calculated LSD. If that point estimate of the difference in the sample means, if that's greater than the value of our LSD, or our least significant difference, then that allows us to reject that set of hypotheses that corresponds to whichever 2 different samples we're comparing. So in this case, we have 3 samples. They all have the same sample size, so we only have to calculate this least significant difference, this LSD value, once. If our samples had different sample sizes, well then we would have to calculate a specific value for this LSD that would correspond to the specific pair of samples that we're comparing. So let's squeeze this in. I scroll down a little bit. Let's fit this in here, our LSD. Oops, so we need our MSE from our ANOVA, which we calculated here was 1.49. 1.49 times 1 over 5, 1 over 5. Those are our sample sizes. Regardless of which 2 we're comparing, our sample size is still 5. And now we need a critical value for alpha divided by 2. Let's do all of these tests at the 0.5 level of significance. So alpha will be 0.025. Now, what are our degrees of freedom? degrees of freedom always corresponds with our estimate of the variance. So here our MSE was 149. We have 12 degrees of freedom that correspond to that estimate of the variance. So if we go into our t-tables, and here's 12 degrees of freedom, probability of 0.025, that gives us a critical value of 2.179. So if I come back here, I have this 2.179. So now we can go ahead and calculate the value of our LSD. I still can't move my calculator. Let's go like this. Okay, so let's calculate the inside of the brackets first. So this is going to be 1 divided by 5 plus 1 over 5 times 1.49. Take the square root of that and times that by 2.179. So our LSD is 1.68. 1.68 is the value of our least significant difference. So now, for each of these sets of hypotheses, we want to compare the difference in the point estimate of the sample means with a LSD value of 1.68. So if we calculate here, we'll put in x bar, I, and j. So for this first one, A and B, so that's going to be 5.4 and 5.6. I forgot to mention one thing. We compare the absolute value of that point estimate against the LSD in order to, so we're just looking at the magnitude of that difference. So this first one, 5.4 minus 5.6, well, that's just going to be 0.2. When we look at A and B, we're A and C. So I'm looking at 8 against 5.4. That's going to be a value of 2.6. And finally, B and C. So I'm looking at these two. That will be a value of 2.4. Now for each of those, we just compare them against Fisher's LSD, and we reject for any comparison where the absolute value of the point estimate of the difference in sample means is greater than the LSD. So for this first pairing, we do not reject, meaning we don't have evidence to show that there's a difference between sample A and sample B. Comparing A and C, 2.6 is greater than 1.68. We can reject, so A and C are different. And comparing B and C, 2.4 is also greater than 1.68. So we can comfortably reject. So what does this tell us? We have here two distributions. We have one distribution where sample A and sample B came out of, and we have a second distribution over here where sample C came out of. So here we have, oops, I kind of went below my limit there. X bar C is out here somewhere. So here we have a case where we have 3 treatments, but they came from just 2 distributions. So both of our different types of toothpastes, they both came from the same population that is less than or lower than, has a lower mean than the control group. The control group with a sample mean of 8 is larger than the two different types of toothpaste additives. So in this case, I cannot say that there's a difference between those two additives, but I can say that they are both statistically different from the placebo, or from the toothpaste that does not contain an additive. Okay, so that's all there is to our Fisher's LSD procedure. It's basically a series of 2 population tests where we have a slightly different type of rejection rule comparing the absolute value of the point estimate of the difference values, or the difference of sample means, to this Fisher's LSD level. Okay, so I hope that helps. We'll do a couple of more. Thanks for watching. Bye.